I'm Joe Gallagher from Veritas Education, and this is the Troubleshooting Disk Backup Resources lesson. This lesson is focused on troubleshooting issues with backups going to disk in NetBackup. So we'll begin with an overview of the different types of disk-related backups that NetBackup supports, and then we'll move into specific troubleshooting scenarios, and we'll have it broken up by category for issues with basic disk, with advanced disk, and with open storage. Before we begin with the troubleshooting information, we'll begin with an overview of disk-based backups in NetBackup and refresh ourselves as the terminology that NetBackup uses and the functionality that the different features provide. Doing backups to disk rather than to tape is an increasingly popular backup strategy, and NetBackup has very robust support for backup to disk. And there are a number of different kinds of disk storage units that I can configure in my backup environment. The simplest of these is the basic disk storage unit, in which case we're talking about individual disks here, or at least individual disk volumes, and each volume is configured as its own storage unit. So if I had 3 drives that I was using as a target for backups, then I would have 3 basic disk storage units configured. So basic disk is very easy to set up. It supports disk staging, which is a form of automatic duplication of backups to another location, such as tape. There's no additional cost or licenses associated with it, but like the name implies, it is very basic. It doesn't support advanced features like air or storage lifecycle policies, and there are issues you can run into with scalability with basic disk. Suppose the storage team provisions 25 volumes for me to use for my backups. I would then need to create 25 storage units in NetBackup and manage the capacity of them individually. That makes administration more complex and unwieldy. I can use storage unit groups, and that'll help me out a little bit, but it still, becomes cumbersome. And so that's where disk pools come into play. The last 3 types of storage units referenced on the slide here are different types of disk pools, and in a disk pool I have 1 or more disk volumes that I have pooled together to be a single destination for backups. And so looking at the next example, advanced disk, let's say I've taken those 25 volumes the storage team provisioned for me, and I created 1 advanced disk pool. Now I treat that pool as a single storage unit in NetBackup. And I say, here you go, NetBackup. I've got this pool of disks that I have configured as an advanced disk storage unit. And tonight we're going to be backing up a couple hundred gigabytes of data. And I'm going to send them to this disk pool. And I want you to do something smart with them. You manage the capacity. You manage the load balancing. Be intelligent about the way you allocate space on these disks. Span if necessary, but don't do it if you don't have to. These are all intelligence that's built into disk pools and advanced disk storage units. So that instead of having to worry about managing each individual disk volume, all I need to manage as a NetBackup administrator is the capacity of the pool as a whole. Do I have enough overall space for tonight's backups? And I don't want to have to worry about which particular spindle a particular backup job is going to. And I also have support in advanced disk for load balancing storage unit groups and support for storage lifecycle policies. So I have more advanced features that are associated with advanced disk. The one really important advanced feature that basic disk and advanced disk don't support is deduplication, the elimination of redundant storage from disk, which is a big trend in the industry. I do see support for deduplication in Pure Disk, and I often see it in open storage. Let me talk about Pure Disk first. Pure Disk is Veritas's deduplication solution for NetBackup, and it's called Pure Disk because this was originally a whole separate product that Veritas offered that was compatible with NetBackup, that was eventually folded into the product, so that Pure Disk services now run natively on NetBackup media servers. And so Pure Disk storage units are associated with media server deduplication pools, or MSDPs. When using deduplication with an MSDP, unique data is written to the disk pool only once, which means that I can store a lot of data with a lot less disk capacity, and in many cases I can have longer retention periods on disk than were possible before. So deduplication is a key enabler for disk-based backups. MSDPs may be created using fast-performing disks such as SAN disks on any NetBackup media server, or another common way of using MSDPs is NetBackup appliances. NetBackup appliances tend to offer better performance and significantly larger capacity than build-it-yourself MSDP pools. Open storage, which was the third row here on the slide. Open storage is really an API which the NetBackup master server supports, which allows third-party non-Veritas vendors to have disk appliances which communicate with the NetBackup master server and have access to some of NetBackup's functionality. The big thing here is, we've seen a lot of vendors making backup appliances that have features such as replication that they could be conducting and NetBackup might not be aware of. You back up some data to a VTL, the VTL replicates the data halfway across the world to some other VTL, now you have 2 copies of it and that's great, but NetBackup only knows about one of them. That was the problem that we were facing. With OST, you can back up your data to a supported virtual tape library or disk appliance, and then the appliance can do something like replicate the data somewhere else, and then inform NetBackup, hey, look what I just did. I just made another copy of the data, so that records are maintained to this in the NetBackup master server, and you have a single point of control for all of your backup data, which is what you want. OST devices also have access to some of NetBackup's features, such as AIR, or NetBackup Accelerator, which particular features a third-party OST device might or might not support is documented in a NetBackup hardware compatibility guide. And so that's a very key piece of documentation if you're working with third-party appliances, because it outlines exactly what they do and what they don't do. NetBackup appliances, of course, support all the features that are in NetBackup. Appliances from other vendors, they pick and choose, okay, my appliance is going to do this and not that. So make sure you check the HCL to see exactly which functions a particular appliance supports. This slide describes some of the disk terminology that's used in NetBackup, some of which is industry standard you're probably already familiar with, and some of which is unique to NetBackup. And so when we talk about a disk enclosure, we're talking about a device that presents disks or disk volumes to NetBackup servers. Now this might be something very simple as a JBOD, just a bunch of disks, or it might be something very sophisticated like a high-end array, or possibly a purpose-built backup appliance. It can vary. But this enclosure is going to present either disks or disk volumes to NetBackup to use as a target for backup storage. In the example that we're looking at here, it's presenting disk volumes. And so there's probably some kind of RAID going on in the background by the enclosure. Now, NetBackup has taken some of these disk volumes, looks like 2 in this example, and pooled them together into a disk pool. And again, the disk pool will be a single destination for backups. So any disks that I pool together get set up as one storage unit in NetBackup. And in this example here, this looks like an example of an advanced disk pool, because we see that there's a NetBackup media server that is zoned to this enclosure, probably across the SAN. And then we see that this media server is acting as the storage server. The storage server is a NetBackup specific term. It refers to the server that really owns and controls these disks. Also, the storage server ultimately writes the data to these disks. In the case of advanced disk, we see one host that's providing both functions. It's a media server and a storage server. So it's the data mover that copies the data from the clients, and it sends it to these disks in the disk pool that it is basically controlling. Now, in other implementations of disk pools, the storage server may not be the media server. In the case of a backup appliance, for example, the appliance itself may be the storage server. That's what happens during OST, which you'll notice is kind of called out on the slide here. When you use a third-party device like a data domain appliance, for example, with NetBackup, and you're using OST, then the NetBackup media server gets an OST plugin installed on it, and the NetBackup processes on the media server hand over the data to this plugin via the OST interface. And then from that point, the vendor's plugin is responsible for writing the data to the appliance. And so in that situation, the appliance is the storage server that's controlling the disks and writing the data. The media server is a separate host that's copying the data from the client and handing it off to the OST plugin. Whenever you use disk pools in NetBackup, there will always be a media server, there will always be a storage server. Sometimes it'll be the same host and sometimes it won't be. It's specific to the type of disk pool you're using. So building on the conversation we were having about the difference between media servers and storage servers, this slide does a great job of kind of laying it all out for you for the different types of disk pool that are supported in NetBackup. Who will the media server be and who will the storage server be? And so in the first example, advanced disk, like we were saying on the previous slide, the NetBackup media server provides both functions. It is the media server, the data mover for the backups, and it is the storage server. It controls all the disks in the disk pool, and it does all of the writes to them. Note that the OST interface is still used even with advanced disk. It's just that instead of having a third-party plugin installed on the media server, it's a Veritas-provided advanced disk plugin. But the data path is the same. You still have a handover of data from the BPTM process through the OST interface to an advanced disk writer to actually write the data. And we'll talk about that in a little bit more detail when we talk about troubleshooting advanced disk. Open storage was our API to allow third-party hardware vendors to provide backup appliances. And so OST devices are always target devices, which means third-party OST devices do not have a media server built into them the way Veritas NetBackup appliances do. They're just a backup target. So that means that the appliance itself is the storage server. It manages its own disks, and the third-party vendor's plugin is installed on the media server and does the writing of data. There still needs to be a NetBackup media server in the equation now. And so the NetBackup media server reads the data from the client and hands it off to a vendor's plugin that's been installed on the media server. Now in MSDP, which is in the pure disk storage unit type, MSDPs have a single host that combines storage server and data mover. So MSDP is another example where the media server and the storage server will usually be the same host. Now I say usually because it is possible to configure load balancing media servers where you have multiple media servers that are credentialed to one MSDP pool. And so in that case, there is one media server which really owns and controls this pool. And the correct vocabulary to use there is to say that there is one media server that is the storage server for this MSDP pool, and that is the only media server that does any writes to the pool. The other load balancing media servers are associated with the pool, but they don't write directly to it, and they don't manage it. They help out with the fingerprinting of data to take some of the load off of the storage server. And so some clients send their data to a load balancing media server to be deduped, but they send their data across the network to the storage server, and the storage server writes the data to the disk pool. So sometimes with MSDP, the media server is the storage server, probably most of the time, but with, sometimes it's not in the case of load balancing. Now, pure disk storage units also include the PDDO, the pure disk deduplication option. Now, this is an older functionality in NetBackup, and PDDO, pure disk pools, have been deprecated. They're no longer configurable, these software-only pools. The only reason why we mention it is because PDDO is still supported in NetBackup 5000 series appliances. These appliances are no longer sold, but we still support the ones that we've sold. And this was NetBackup's original deduplication solution, where you had a pure disk pool, which was basically a target for backups. And NetBackup would be handing off the data to Pure Disk. And Pure Disk was basically a whole separate encapsulated backup product, that NetBackup acquired when it was part of Symantec. So in a Pure Disk setup, it's actually very similar architecturally to the way Open Storage works with other third-party vendors. There's a NetBackup media server, that's the data mover, and there is a Pure Disk storage pool, and within that pool, there is a Storage Pool Authority, or SPA. The Storage Pool Authority server is the storage server for NetBackup's purposes. In the case of the appliances, the NetBackup 5000 series appliance is the storage server, and then somewhere there is a NetBackup media server, which is sending data to that appliance. The 5030s are perfectly fine devices. It's just that they function only as target appliances. And that's compared to the newer 5230 and 5330 appliances, which have integrated NetBackup servers on them. And so they can be configured as a media server, and in the case of the 5230, it can even be a master server if you want it to. And that's kind of the direction Symantec and Veritas are moving in there with integrated appliances. I mentioned appliances several times in the previous slides. Here's kind of a recap of that information. A lot of times disk pools will be provided in an appliance form factor these days. Appliances are very popular with customers because they provide a dedicated hardware for backups where you have a disk enclosure that's been optimized for maximum backup performance and scalability. NetBackup appliances originally came in a PDDO 5000 series format and an MSDP 5200 and 5300 series format. The 5030 was the last of the 5000 series, no longer sold, although it is supported. And so for the most part, when we talk about NetBackup appliances these days, we talk about the ones that have integrated media servers. And that's the 5200 and 5300 series. The 5230 and the 5330 are the most recent ones in those series. The 5230 can be a master or a media server. The 5330 can be a media server only, although it also has considerably more performance and capacity than the 5230. And being able to get NetBackup in an appliance form factor has a lot of advantages. It greatly reduces the complexity of your implementation. It saves time. It saves cost. It's a true single vendor solution. One throat to choke, folks sometimes like to say. Any issues you have, your support comes from Veritas. And in addition to supporting our own appliances through the OST program, Veritas also supports a number of third-party vendors. So if you've already gone out and bought a Falcon Store, Data Domain, Greenbytes, if you take a look at the hardware compatibility list, there's a large number of backup devices that Veritas supports through the OST interface. And these may have capabilities to do things like replication or error. Again, the hardware compatibility list is really the guide for this to show which specific functionality a particular appliance supports. Third-party OST appliances are always target backup devices. They don't incorporate a NetBackup server the way the Veritas appliances do, but they will support some of the OST features. Again, the hardware compatibility list is your guide for that. Here we have an example here where we're using a third-party OST vendor, a non-Veritas appliance. And so in that case, we're using Open Storage, OST, and the NetBackup media server is the data mover, copying data from the client. And then once it has the data from the client internally on the NetBackup server, the data is handed off from the NetBackup services to the OST plugin. This is a vendor-provided plugin which has been installed on the NetBackup media server. So NetBackup hands off the data to this plugin. The plugin is responsible for sending the data to the appliance. That might be a SAN or a LAN transmission, depending upon how it's configured. And so in this example over here, the Open Storage appliance is the disk pool and the enclosure. It is also the storage server. And so this is a good example of when in a NetBackup environment the storage server and the media server would not be the same host or appliance. Architecturally, The NetBackup Remote Manager and Monitor Service, NBRMMS, is very important to managing disk pools in NetBackup. This is a service or a daemon that starts when the server comes up. It's always running, even if the server doesn't have any disk pools configured. In that case, it just doesn't do anything. But when you have disk pools configured, it's responsible for some of the management and reporting. NBRMMS is a service container in the same way that NBEMM is on the master server, and so it's a parent process that contains a number of subsystems. The disk polling service, or DPS, is responsible for querying the disks that are managed by this media server on a regular basis and reporting their status up to the master server. So that, for example, when you go to a report in the NetBackup admin console to see the status of your disks and their available space, that information is being fed to the master server via this component. Another one of the subsystems in NBRMMS is the Remote Disk Storage Manager, RDSM, and this is what's really responsible for the creation and management of disk storage units. It's also responsible for handling the opening of OST plugins. Let's discuss the maintenance and troubleshooting of basic disk storage units. As we discussed in the first topic in this lesson, basic disk storage units are different than all other types of disk in NetBackup because there is no disk pool object. Basic disk is just a single disk. Really, it's a single path. So theoretically, you could have multiple basic disk storage units targeting the same disk, although that is not a best practice. In fact, it's a terrible idea. Don't do it. But so with basic disk, you have a direct path to a location on a single disk. So each disk becomes a storage unit when we talk about basic disk. And basic disk is pretty simple the way it operates. Out of all the different kinds of disk storage unit, basic disk is the one that's most similar to Media Manager storage units. So what are some differences? Well, obviously, when you talk about disk, there's no tape mount. So all of those Media Manager processes that were responsible for loading tape cartridges and unloading them, there's none of that. But we still do use the Tape Manager process, BPTM, for the writing of data during backups and the reading of data during restores. Again, all significant activity, reading and writing of data, backups or restores, uses BPTM. This separate BPDM process, which used to do those things in way older versions before 6.5 of NetBackup, nowadays has been relegated to mostly housekeeping. It helps out with basic disk staging for the cleanup of the disks, and it's still used for the read side of duplication. Basic disk storage units support disk staging, which is an automated form of duplication that's completely encapsulated within the basic disk storage unit. It doesn't use a storage lifecycle or anything like that. In fact, you can't use basic disk with a storage lifecycle. But this does provide you a way of automating the creation of a second copy of the data. Essentially what happens is data comes into the disk during the backup job as normal, and when the backup job is complete, the data remains on disk for as long as possible. And what's going on here is there is a periodic relocation job that is configured, and this is a little schedule that's part of the basic disk storage unit. Now, NetBackup calls this a relocation schedule, which is probably not the best term to use because we're not really relocating data. We are copying data. This is not a move or a cut. It's a copy. So when the relocation schedule runs, you're going to have two copies of the data. And typically that'll be one copy on disk and one copy on tape, although that's not the way you have to do it. Both destinations could be disk. And the relocation could target more than one device if you wanted more than two copies. That's supported. But that's kind of the typical way of using this. One copy on disk, one copy on tape. And the retention period controls the retention on tape. That final destination for the data is going to remain there for as long as the schedule originally said. So if the schedule said 6 months, it's going to stay on tape for 6 months. Now that first copy that we made to disk is not going to be there for 6 months. It's going to be there as long as it can be until the disk runs out of space. And what happens is when the disk reaches its high watermark, NetBackup is going to pause whatever backup job is in progress. It's going to generate an image cleanup job on that disk. It is going to delete the oldest stuff on the disk, and it's going to delete as many images as it needs to until it gets below the low water mark. That's the function of the low water mark with basic disk staging, to control how much stuff gets deleted during cleanup. Now, theoretically, I could set the low water mark at 0, which would mean every time the cleanup runs, it just deletes everything on the disk. But most of the time, I don't want to do that. It's nice to leave stuff on the disk for as long as I can, because I get great restore performance coming off the disk, especially for individual files. Note, though, that I don't have a lot of control over what gets deleted. This is strictly a first in, first out situation. The only real rule here is that NetBackup can only delete stuff that has been duplicated. So if a relocation of a particular image has not happened yet, and we're at a room on the disk, images that have not been duplicated cannot be deleted. It's the only copy of the data. We can't get rid of it. So it is possible to still get failed jobs due to a full disk, status code 129, even when I'm using basic disk staging. And what that should say to me is I'm just not running my relocation job often enough. Some general suggestions when working with basic disk: avoid sharing a volume or file system between basic disk storage units. Like we mentioned before, basic disk storage units do target a path, usually a directory on a disk, but you really want to have just one basic disk storage unit per disk, particularly if you're doing disk staging. Having multiple disk staging storage units targeting the same disk is a recipe for confusing the heck out of NetBackup. Don't do that. Now, basic disk does not support storage lifecycle policies. It has its own disk staging option that you can use built into the storage unit, but it doesn't support any of the other advanced features that SLPs do. Only disk pools support that. It also doesn't support media server load balancing in storage unit groups. Again, only disk pools are smart enough to do that. One thing that you can do with basic disk, though, is you can span disks. So if I have multiple basic disk storage units that are associated with the same media server and they're in the same storage unit group, I can span. So if I've got a media server with 3 basic disk storage units, I put them all in the same storage unit group, and if one disk fills up, I can span right over to the next one, and their job doesn't fail. There's no interruption or anything like that. Very desirable functionality. Was a customer request for a long time before it was implemented. Note that spanning is not supported with basic disk staging. When you think about it, with disk staging, you wouldn't want that kind of behavior, really. In terms of maintenance that's required for basic disk storage units, probably the biggest thing that's going to be on our minds most often as an administrator is making sure that these disks don't become full. And the high watermark helps me out with that. The high watermark is the point at which the disk gets marked as being full. No new backups can go to that disk once the high watermark is reached until some of those images expire. And so backups that are already running at the time this high watermark is reached continue to run, hopefully successfully, but nothing new can go there. So, the idea is I want my basic disk storage units to be able to get almost completely full, but not absolutely full. If you have a disk that fills up 100% and there's still more data to write and there's no room to put it, and the disk spanning is not possible, then you're going to get failed jobs. You're going to have to go all the way back to the beginning and start again, which used to be one of the big pain points with disk backups. So high watermarks help out a lot. If you're getting disk full conditions frequently, lower your high water mark. And, of course, also consider the fact that you may just need more disk space. The low water mark, we mentioned previously, is only used if you're doing disk staging. And it just tells NetBackup how much stuff to delete when it's time to do cleanup on that disk. And again, we don't usually want to delete everything, not if we can help it anyway. We'd like to delete enough stuff so that tonight's backups run successfully, so that I don't have to keep pausing multiple times during the backup window to keep deleting data to free up space. And so you want this to be set so that you're keeping some stuff, but there's still enough room for tonight's backup. testing is going to be required, to find the right number. The default of 80% is going to be pretty good in most environments, but it may require adjustment in specific cases. Remember that with disk staging, it is the high watermark that is the trigger to do disk cleanup, not a disk full condition, but a high watermark condition. There's a number of different places within NetBackup where you can get information about basic disk storage units. They show examples here of the reports. The disk storage unit status report gives me information about my total space in my basic disk storage units, how much space I've got, how much is in use, and how much is available. NBDev query from the command line would give me similar information. And of course, operating system tools like Windows Explorer or DF can also be used, if I'm working on the assumption that each storage unit is a single disk. Op Center is also another great way of keeping track of disk space. There's no examples on the slide here, but Op Center has a plethora of disk reports that can be run to monitor your health and capacity of your disks. This slide shows some common basic disk status codes. Status code 12 is a file open failed, and status 12 is actually something NetBackup is doing on purpose. NetBackup kicks up this error when it's being instructed to write data to a directory on the root file system or the system disk in Windows. And by default, NetBackup doesn't want to do that. The default setting for basic disk storage units is never to write backups to root or to the system disk. Because when you think about it, it's a terrible idea to write a big pile of backups to the root file system, because if I fill up the file system, I'm going to bomb the server. Now, in Windows, this is not that likely to happen. In Windows, backups would only go to the C drive, the system disk, if I was the sort of foolish person who actually put the C drive down as the destination, in which case I deserve everything that I have coming to me. In Unix or Linux, however, this can happen when a file system is unmounted. So NetBackup goes to write data to the file system, someone has unmounted the file system, and so by default, then NetBackup is going to be looking to write data to the mount point itself, which is within the root file system. So this is really a safety valve that prevents something silly from happening, and normally an unmounted file system on a Unix or Linux system is the cause. Now, 84s or 85s are write errors and read errors. So I'd usually see an 84 on a backup, an 85 on a restore, and of course I have to consider physical issues that the disk may have gone bad. I also can look for configuration issues. With the 84s, make sure that the fragment size in the storage unit is not greater than the maximum file size the file system supports. Back in the old days when we used to have the 2 gig file size limit on some file systems, that used to happen kind of frequently. Nowadays, most file systems support pretty big file sizes, so it's less likely that that's the issue, but it's something to always consider. The storage code 129, the disk storage unit is full, very specific. You got a full disk, and that's why the backup is failing. Remediation for this is either to increase the amount of disk space available or to consider lowering the high watermark so that disks get marked as being full sooner, and that can make a big difference if you're using something like storage unit groups, where instead of NetBackup writing data to a disk that's almost full, it then chooses a different disk instead because the high watermark has been met. So changing the high watermark isn't going to create disk space for us where it doesn't exist, but it might improve the efficiency with which NetBackup uses my disks. Back in the old days, full disks used to give us an 83, a media open error, that got changed a few versions ago to status code 129 instead, which is a more specific status code. The 213 is no storage units available for use. You can get that if you're using the any available destination in the policy. Instead of specifying a storage unit or a storage unit group, you specify any available, and all of the storage units are marked as being on demand only. Now, we don't recommend using the any available setting in your policies, but it does still exist in the software, and it's specific to disks because disks are marked as being on demand only by default, which means that they're never going to be used for a policy that's asking for any available storage unit. That's a real old behavior in NetBackup. that Media Manager storage units default to this being unchecked, and disk storage units default to it being checked. Again, a pretty specific status code. If that's what you see, that's probably the problem. 219 is a much broader code. The required storage unit is unavailable, and it can happen from physical or logical issues. Checking for typos when the disk storage name was entered is a possibility. One that's only going to come up if you were creating storage units from the command line, not if you were doing it from the console. And then the 2074, which is a newer status code, a disk volume is down, means the disk is not accessible. Probably this means a loss of connectivity to the disk or the failure of the disk, one or the other. The host can't see it anymore. Next, we'll discuss the maintenance and troubleshooting of advanced disk pools. Advanced disk is the simplest implementation of disk pools in a NetBackup environment. And we mentioned already that disk pools have a number of advantages over basic disk. The way they have intelligent management of capacity, automatic disk spanning, support for storage lifecycle policies. There's a lot of advantages to using disk pools. The scalability is much better. The way you can pool together multiple disks into one pool, and then that becomes a single storage unit instead of having one storage unit for every disk the way you do with basic disk. Advanced disk, I mentioned, is the simplest way of deploying it because there's absolutely no hardware dependency. Any disk can be part of an advanced disk pool. Probably in a real-world environment, what we're talking about here are SAN disks that I've pooled together that are all under the control of a single media server. Remember that in advanced disk, the media server and the storage server will be the same host. Now, there's no rule that NetBackup enforces about this. You know, if you wanted to have some internal disks that are set up as an advanced disk pool, that's fine. You know, the only thing I would say is be careful not to put disks of vastly different performance in the same pool. You know, you pretty much want all the disks or LUNs in your advanced disk pool to be identical. Taking a look at the process flow with advanced disk pools. Now, we've mentioned already that media servers are the data movers for advanced disk, as they are with any disk pool, and that the media server will almost always be the storage server for advanced disk pools. And the only time this won't be true is if you have some disks that are being shared through NFS or CIFS, which is supported. So in that case, we've got one host that's sharing out these disks, and then you may have other media servers that have access to them through NFS or through CIFS. The NBRMS process is used for creating these pools and is used for management and reporting. The BPTM process is used for the actual reading and writing of data. Also possibly involved with advanced disk is the NBST-serve process, which is used for advanced disk staging. What this really is this is really storage lifecycle policies that have capacity managed retention configured. So this is unlike basic disk, where disk staging is a function of the storage unit. With advanced disk, if you're doing staging, and you may or may not be, you're doing it through a storage lifecycle. So we'll talk about that in the lifecycle policy lesson. This slide provides a review of the configuration of advanced disk pools and storage units, something which is covered in the regular 5-day NetBackup admin course, but just to give a high-level refresher, we need to have a storage server, which will be one of my NetBackup media servers. So if my media server has already been configured to be a storage server for advanced disk, great. If that has not happened yet, then there's a wizard I run, simple configuration. And then I'm going to create disk pools, a wizard-driven process where I select which disks I want to be part of the pools. Basically just gives me a display of all the file systems that are visible to that server. And then once the disk pool is configured, I can create storage units. And usually there'll be one storage unit per advanced disk pool, although there may be some situations where there might be more. And then lastly, I might or might not configure a storage lifecycle policy. Now, there's no requirement to do this. You can have a policy that writes data directly to an advanced disk storage unit, but in many cases I may want to use some of the advanced features that storage lifecycles provide, like the ability to do automatic duplication or the ability to do disk staging, and so if so, I would configure a lifecycle. Here's an example of an advanced disk storage unit that I have configured. You'll see that there is one media server associated with this, which will typically be the case with advanced disk. You'll see that the target is a disk pool, which I have created. And if you look at the disk pool properties, you can see the number of volumes and the total capacity of the pool. Now, if you wanted to get more detail about which specific volumes made up that disk pool, you'd need to go to the disk pool properties, which is what they're doing in the example off to the right here. Right-click on the disk pool object itself and select Change, and then I can see the actual disks. Looks like 3 Windows drives in this example here that make up this pool. Note that the high watermark and the low watermark are controlled by the disk pool when you talk about advanced disk, unlike basic disk where it's part of the storage unit. Note that as with all disk storage units, there is a maximum concurrent jobs. That would be the maximum number of backup jobs that could ever go to this storage unit at any given time. Backup or duplication jobs would count against that limit. But notice that in the disk pool object, there is also a limit I/O streams, and the difference here is max concurrent jobs at the storage unit level is the total amount of backup or duplication activity for the whole pool. No more than this number of jobs at any given time. But it doesn't say which job is going to which disk within the pool. It's just a total count. The limit I/O streams tool in the change disk pool settings, that really is a per volume setting. And so you expect there to be a relationship here. Let's say, for example, that these 3 drives here are coming off of a JBOD, and the disks, I think, there is some RAID going on, so I think that they're good for 3 simultaneous jobs each. And so I think 9 total is a good number for this pool. So in the disk pool, I say limit I/O streams to 3 per volume, and in the storage unit, maximum concurrent jobs gets set to 9. Note that max concurrent jobs at the storage unit only applies to backups and duplications, in other words, to writes, whereas limit I/O streams at the disk pool level is a little more comprehensive than that. It takes reads into account as well, and that can be important for disk pools that might be doing replication, because replication sometimes is happening during the backup window, and it's nice to be able to take that into account so I don't thrash my disks. The only thing that really doesn't count against either of these limits is restores. Restores will always run if the resources are available. You can never, restrict a restore from running with either of these settings. Some general information about advanced disk pools. Don't share disks that are used in advanced disk pools with other users or applications. These disks should be used exclusively for the disk pool. NetBackup has no way of enforcing this, unfortunately. A local administrator could always choose to put additional data on a disk other than NetBackup data. It's a bad idea, and it's strongly discouraged, particularly if you're using disk staging. Now, data on advanced disk can be encrypted using NetBackup's Key Management Service, or KMS. Spanning is possible. In fact, it happens automatically. That doesn't need to be part of a storage unit group or anything like that, the way basic disk does. And like we mentioned before, sharing of storage is possible. There's no facility to allow sharing of disks in advanced disk pool within NetBackup. However, if you have a media server that's going to use NFS or CIFS to share out these disks, then you can use that to have multiple media servers with shared access to a disk pool. Performance across NFS and particularly CIFS is not so great. But if that's a necessary solution, it's something that can be done. And there's more detail in the NetBackup Advanced Disk Storage Solutions Guide. Maintenance of an advanced disk pool is similar to what we were talking about with basic disk. The disk pool itself has a high watermark and a low watermark. So again, the high watermark can be adjusted so that disks are marked as being full sooner. Each disk within the pool has its own high water mark, and then when all the disks in the pool have reached their high water mark, the entire pool is unavailable for further backups. For the most part, as the administrator, you won't notice when an individual disk hits the high water mark. It's only when the pool as a whole is running out of space that you need to intervene. That's one of the whole advantages to advanced disk. You don't really worry about individual disk capacity. You worry about the capacity of the pool as a whole. The low water mark also at the disk pool level, and as with basic disk, only matters if you're doing staging. When you're doing staging with advanced disk, if you're doing it at all, you're doing it with storage life cycles, and so the low water mark tells the life cycle how much data to clean up off of that disk when the high water mark is reached. There are many areas in NetBackup where I can get information about my advanced disk pools and about the storage units that target them. So under Reports, there's a number of disk reports that can show the status of storage units and the status of disk pools. The Device Monitor will show me whether disk pools are up and available or not. Disk pools have this characteristic the same way tape drives do, and it means exactly the same thing. Disk pools that are up are available for use. Disk pools that are down are not. And then this information is also available from the command line, a number of examples of which are shown on the slide here. NBDev query probably being the one that's most commonly used. It gives the most useful information. And note that Op Center is also an option. If you're using Op Center in your environment, there's a number of great disk reports that could be run from there as well. Disks in a disk pool have a status of either up or down. It means the same thing it does for tape drives. Disks that are up are available for use. Disks that are down are not. And so the individual volumes within the pool have a status, and the pool as a whole also has a status. And we can verify what the status is either from going to the Device Monitor in the admin console or by using the NBDev query command from the command line. And you can see the two different forms of the command illustrated here, the -list dp to see disk pool status, and the list dv to see disk volume status. Also note the nbdev config command. nbdev config can be used to make changes to disk pools. In the examples here, they're using the change state argument to change the state of either a disk pool or a disk volume, depending if you're using the -dp or the -dv to mark the pool or volume up or down. Something you might do for maintenance. If you're planning on taking a disk volume offline for maintenance, here's an easy way of doing it. Note that it is also possible to merge two existing advanced disk pools together. That's an offline activity. I've got to take the disk pools down in order to do that and delete the storage units that reference them. Then I can take two smaller pools and merge them together into one big pool. It's also possible to use nbdev config to add or remove volumes from a disk pool, or to delete the disk pool entirely. Adding a volume is pretty straightforward. nbdev config with the -addv argument. Removing a volume requires taking the pool down and then taking the volume to be removed down. Remember that the state of volumes and pools is separately maintained, so I've got to do both those actions. And then I can use the -delete dv argument to remove a disk from a pool. Obviously be very careful before you do this to make sure that that volume you're removing does not have any active images on it. If I did, I would need to duplicate them somewhere else or expire them before removing the volume. And last example, delete dp to delete the entire disk pool. Now NetBackup is going to require you, in addition to taking the disk pool down, to delete all storage units targeting the disk pool first, to avoid creating inconsistencies. So you kind of may wind up, if you want to delete a pool, having to go through and delete all the storage lifecycle policies that are using that pool first, and then delete the storage units, and then delete the disk pool itself. It's NetBackup's way of preventing anomalies from creeping into your configuration from objects that are deleted that leave a hole in your configuration. NetBackup periodically runs image cleanup jobs, and those image cleanup jobs are responsible for deleting images on disk that don't need to be there anymore, expired images, or images that have the expire after duplication setting set. And what happens during an image cleanup job, bpimage-cleanup is used, and that command calls the nbdelete command. Now, if for some reason this disk storage unit is not available because the disks are offline or because the media server that's hosting it is offline, this file deletion gets rescheduled for when the storage unit is available. Now, although this happens automatically fairly frequently with image cleanup jobs, this is a minimum of once every 12 hours, and in most environments a lot more often than that, it is possible to initiate manually. As you see on the slide here, nbdelete-all volumes-force will force an image cleanup job to run. And if there are images that have expired that don't need to be there, this will trigger their deletion. So if you're looking to free up every last iota of space that can be freed up in your disk pools prior to the backup window, this is a command that you can use. Some other miscellaneous troubleshooting information here. Remember that if disk volumes become unmounted, when NetBackup detects that, it'll mark that volume as being down. When the file system becomes available again, it should automatically get marked as being up, but there may be times when you manually have to do this if there's been a problem. When you're going through and creating advanced disk pools, the best way to create any disk pool, especially dedupe pools, is to use the console and to use the wizard. If you're doing it from the command line using the nbdevconfig command, you have to be very careful when you're specifying the storage type. After the -st would be the words advanced disk in title case. It's very easy to make a typo there, especially in the middle of the word where there's two D's put together, lowercase and uppercase. And if you make a boo-boo here, there's no error checking of this syntax. NetBackup is just going to accept it, but then it's not going to work. The reason why there's no error checking is because storage type applies not just to things like advanced disk that are native to NetBackup, it applies to other vendors, third-party vendors supported through OST, and so NetBackup doesn't validate every possible name for every possible storage device, that's out there. Long story short, watch out for those typos. The classic symptom of this is if you see a storage server set up as the MDMP type when it's not supposed to be, that probably means that you made a typo, and NetBackup doesn't know what to do with it, and NDMP is just the first one on the list internally in the database. You can get information about troubleshooting this and other issues from NetBackup reports, from the admin console, from Ops Center, and from the debug logs, particularly those for NBRMMS and NBSTSServe. Remember that NBRMMS is a service container, and it's really the OIDs for its subsystems that you're probably interested in, not the parent process itself. This slide shows some common exit codes with advanced disk pools. The 83, the media open error, means that the disks cannot be accessed, probably because they're unmounted. And the timing here is, normally NetBackup detects when they're unmounted and marks them as being down, but in this situation it happened before NetBackup automatically detected that they were unmounted. It's also theoretically possible to get this in Windows if you have the disks and they don't have drive letters assigned. The 2067 is a drive volume not found, so we're doing a restore or a duplication, and it's referencing a disk volume that doesn't exist in the NetBackup database. On the right side, this can happen if we've had a major boo-boo where we have a disk pool configured that contains no volumes. The 2073 and 74 mean that either the pool or the volume is down and inaccessible, and so I've got to figure out why it's down. Most often this will be connectivity, although I also have to consider physical device failure. In this last topic, we'll talk about maintaining and troubleshooting open storage disk pools. As we've mentioned earlier in this lesson, OST is an API that Veritas provides that allows vendors to make backup appliances and allows them to communicate with the master server. And so the master server is aware of actions that the appliance may be taking, like replication. And it also allows access to some of the advanced net backup functionality, such as AIR. Whether or not a particular appliance implements a specific feature or not is up to the vendor. The hardware compatibility list will be very specific about exactly which features are supported by a particular appliance. Now, when we use third-party OST devices, in other words, an appliance from anybody other than Veritas, there's going to be a plugin that gets installed on the media server, and the NetBackup processes are basically going to hand off data to that plugin, and then the plugin writes the data to the appliance. When we talk about third-party OST appliances, the disk appliance itself is always the storage server. It manages the disks and it manages the writes to the disk, and one or more NetBackup media servers will be sending data to this storage server to be written to the appliance. Now, depending on the device, OST devices might be SAN attached or they might be network attached. A lot of them are network attached, and so in many cases it's possible to have multiple NetBackup media servers that are associated with the same appliance. We could be using storage unit groups in NetBackup to do load balancing between these media servers. Sometimes some OST plugins like Boost allow for this functionality natively without using storage unit groups. So it is fairly common to have multiple media servers associated with a specific OST appliance. Here's some gotchas when working with OST in NetBackup. Remember that you've got this OST plugin that is installed on the media server, and that we have to maintain a proper version of that plugin. So if I upgrade my NetBackup version, I may need a new plugin. If I upgrade the firmware on the appliance, I may need a new plugin. And NetBackup doesn't, track that kind of compatibility. NetBackup doesn't know what version of the plugin you need to work with a particular firmware version on a particular appliance. That's up to us to maintain that. Don't enable client-side compression or encryption in the backup policy. Don't do that, by the way, with any dedupe pool, even a Veritas pool. You don't want to do any compression or encryption before dedupe, because it'll mess up your dedupe rates, especially encryption. Let the appliance do that. Any good appliance vendor has the ability to do compression and encryption as part of the dedupe process, so that the data gets deduped first, and then it gets compressed or encrypted. That's what you want to have happen. Veritas pools do that, and again, any good vendor will do it that way. Other thoughts: if you're getting licensing errors when you try to configure the disk pool, check your bp.conf, verify there's only one client name entry and that it is accurate. If the plugin crashes, usually because of a compatibility problem, it may cause BPTM or BPSTS info to crash as well in core dump. Again, check compatibility there. Make sure you're using the correct plugin for this NetBackup version and for the firmware level of the appliance. Here are some NetBackup commands that may be helpful when troubleshooting third-party appliances. And we mentioned that NetBackup can't tell you what the correct version of a plugin is, but it can at least tell you which version you're running. Here's where I can use BPSTS info to see which plugins have been installed on a media server and which version they're running. I can also display all of the storage servers and credential information. It's very likely that there may be OST tools that are provided by the vendor as well that can provide much more information. Most appliance vendors will provide some kind of a web-based interface to the appliance where I can get a lot more information. When troubleshooting failed jobs on the NetBackup side, the admin and the BPTM logs can be very useful, and in many cases the plugins will kick information back to BPTM. So search for the name of the OST storage server, such as data domain in this example, to see if there's any messages captured in those logs. And you also might want to check out NBRMMS and STS and their subsystems for more information. And you might want to check the vendor-specific logs, which will probably be located possibly on the media server in the directory where the plugin is installed, or they might be on the appliance itself, or both places. You got to figure out when you're troubleshooting, is the problem on the net backup side, or is the problem on the appliance side? For failed duplication, the same logs essentially are useful for duplication as they are for backups. When it comes to restores and duplications from OST backups don't necessarily use the same media server that wrote the backup. And that's a big exception from the way NetBackup normally behaves. Normally with Basic Disk, with Media Manager, the media server that did the backup does the restore. Now that's not true with OST. It's actually not true with any kind of disk pool, Veritas or another vendor. Anytime you have multiple media servers associated with a disk pool, when it's time to do a restore, NetBackup will do a load balancing algorithm, find the media server with the lightest load, and assign that media server to do the restore. And NetBackup thinks it's being helpful by doing this. It'll give you the best performance. And in many cases, it's a handy functionality. But it can be some gotchas with this, especially because maybe I have multiple media servers associated with the pool, but I've got some firewall configurations where not all of these media servers can see every client. So it may be necessary to create the touch file referenced on the slide here, use backup media server for restore, to force disk pools to behave the same way other types of restores behave in NetBackup, so that the original media server does the restore. In this lesson, we did an overview of disks and disk pools in NetBackup, and we examined specific troubleshooting situations for Basic Disk, Advanced Disk, and OST.